Hi everyone. We are talking about inverse functions and their derivatives. So the first thing we're going to look at is just the graphs of a function and its inverse. So say we have some function like a quadratic or something like that. Okay. As we learned before, its inverse will be the same shape but reflected about the line y equals x. Okay. So whereas I did follow along the y-axis before, now I follow along the x-axis. Okay, now this is not the same thing as just like a 90-degree rotation. Okay, it's not a 90-degree rotation, it is an actual reflection. Okay, we flipped it. Okay, a big thing to remember is that the domain and range of a function flip for the inverse. So the domain of the original function is the range of your inverse and vice versa. Okay, and then the range of your original function is now the domain. That makes sense because the range is all the y values. And for the inverse function, now we're looking at the x values. Okay, so the shape is the same, but now it follows along the x-axis instead of the y-axis. So the range, what was the range is now the domain. What was the domain is now the range. Okay, so that flips. And some properties here that you can take a look at. So the first thing we're going to do is look at the graph of square root of x minus 1 and the inverse. Okay, so first thing we're going to do is find our inverse. Now, remember to do that, all we have to do is flip x and y. So we're given y equals the square root of x minus 1. All we have to do is flip x and y and then solve. Okay, so I'm going to square both sides and then add 1. So this is my inverse. Okay, now we're going to graph it. So for part B, so the graph of the square root of x minus 1 is just the parent function shifted to the right. Ooh, that's definitely a 1. Okay, now what I have here is a quadratic shifted up 1. All right, so notice the similarities. Notice how all I did was I really reflected it across. Now, you might be wondering why there is not another thing here to finish the parabola, and keep in mind that's because this is only positive. There's no plus or minus here, right? And a square root function only exists for positive numbers on the inside. You can't have a negative on the inside, so it can only output positive numbers. So because this is squared, you end up getting both sides. So that's kind of the weird relationship between a square root and a quadratic. Okay, but that's our graph. Okay, now we're going to describe the relationship. We already talked about that. It's reflected about the line y equals x. Right, and last thing we have to state the domain and range of both of them. Okay, well, that's not bad. So for my original function and then for my inverse function, so I'll just make that distinction here. So my domain is my ranges, my domain is my ranges. Okay, so for my original function, my domain is everything after 1, including 1. My range is everything greater than 0, including 0. Okay, now for my domain here, it's all real numbers, okay, because it's my parabola. And then my range is everything bigger than 1. Okay, so notice what's similar, what's different. Okay. Now again, if we had a plus or minus in front here and we finish this parabola, then hypothetically, our range would be all real numbers for this. Okay, then it really would have just flipped. But because it's not, it's a little different. Okay, let's move on. All right, we're going to do a quick exercise. So given f of x equals x cubed and then inverse x equals the cube root of x, we're going to find a couple things. So first we need to evaluate f of 2. So 2 cubed is 8. Okay, then we need to find f prime of x. So we're going to take the derivative, which is just 3x squared. Okay, and then we need to find f prime of 2. Well, 2 squared is 4 times 3 is 12. Okay, now we need to find f inverse of 8, so the cube root of 8, which is 2. Now I want to find the derivative of f inverse of x. Okay, well, the derivative of the cube root of x, which is the same thing as x to the 1/3, is 1/3 x to the negative 2/3. Okay, now they want us to plug 8 into this. So, okay, well, the cube root of 8 is 2. And then we're going to square that, so it's 4, but I have to flip it, so it's 1/4. So 1/4 times 1/3 is 1/12. Hey, look at that. Look at that. So it asked me what I know is between C and F. Well, they're reciprocals. All right, look at that. All right, that's very important. So from here, we can deduce something. Okay, now notice the numbers that we plugged in. On part A, B, and C, we plugged in 2. On parts D, E, and F, we plugged in 8. And that's very important because the point that we were working with was 2, 8, right? So when the x value that I plugged in here gave me a y value of 8, and then the value I plugged in here gave me 2. Okay, so the values that I'm working with, the point was 2, 8. That was the point I was working with. So keep in mind what we plugged in. Okay, we plugged in 8, which is the y value. Here we plugged in the x value, which is 2. D, E, and F, we plugged in the y value, which was 8. And when we plugged in the y value to the derivative, it gave us the reciprocal. Okay, and that's actually going to be a general rule. So I kind of dislike the way that they write it here. I prefer this notation. So f prime of x equals 1 over f inverse prime of y. Okay, so what I mean by that is the derivative of some function is equal to the reciprocal, so 1 over the derivative of its inverse with the y value plugged in instead of the x value. And that's exactly what we just did. We plugged in 8 instead of 2 because 8 was the y value. We found that it was the reciprocal. And you might be asking, like, why is this useful? Well, this is useful because if I ask you to find the derivative of the inverse evaluated at a point, it's very easy because it's just the reciprocal of your original function evaluated at x. Okay, that's why this is useful. Let's practice this. Okay, it might seem a little confusing, the notation here, but once we start working some problems, hopefully it makes sense. So we're given f of 3 equals 5, which means we have a point 3, 5. Okay, x value is 3, y value is 5. And we're given f prime of 3 equals 7 halves. Find f inverse prime of 5. Now, at first, this problem might not make sense because like 5 is not the same number as 3, but because we're working with an inverse, we indeed are working with the same point. Okay, 5 is just the y value, and 3 is the x value. So f inverse prime of 5 is equal to 1 over f prime of 3. Okay, again, that's why this is important, because this is the y value, which is 5. This is the x value, which is 3. So that's just going to be 2 over 7. Hey, not too bad, right? Not too bad. We just do a reciprocal. Okay, sometimes we don't have everything. Sometimes we don't have everything, and we need to figure out what we need. So they want us to find f inverse prime of 2. Okay, what this tells me is I have some point, and 2 is the y value. Okay, 2 is the y value because that's what I'm plugging into my inverse. So I need to know the x value. I do not know the x value, so let's find it. Okay, let's plug 2 in for y. And we have to solve for x. This one ends up working really nicely because I recognize this as something that I can factor. Okay, I recognize this is something that I can factor. Would I expect you to be able to see that? Probably not. You could use your calculator for this maybe, but you can indeed factor this. And so we end up getting x equals 1. And this is always going to be above the x-axis, always going to be positive, so this has no solution. So I end up getting x equals 1, which means that 1 is the x value that I was looking for. All right, so my point is 1, 2, which means that f inverse prime of 2 is equal to 1 over f prime of 1. Okay? I don't know what f prime of 1 is, so let's find it. Okay, so I need to know what f prime is first of all. So let's go ahead and evaluate f prime, which is 3x squared plus 2. And all I need to do is plug in 1. Okay, so I end up getting 5. Alright, let's keep going. Same deal here. Okay, they want us to find g inverse prime of 2, which again means that 2 is my y value. I need to find my x value. So I'm going to plug 2 in for y and solve for x. So I end up getting 3, which means my point is 3, 2. So g inverse prime of 2 is equal to 1 over g prime of 3. Okay, well, I don't really know what g prime is in the first place, so let's find that. So it's 1/2 x plus 1 to the negative 1/2. I just have to plug 3 into that. Okay. We end up getting 1/4, and so 1 over 1/4 is just 4. Okay, and last one, this time working with trig. Okay, they want us to find f inverse prime of root 3 over 2. Okay, so again, I have some point. I know root 3 over 2 is my y value. Need to find my x value. So I'm going to set this equal to my function, which is cosine, and I'm bounded between 0 and pi. So when I do arc cosine, root 3 over 2, I know that this is just going to be pi over 6. Okay, I do not have to include, I guess, 11 pi over 6. Just pi over 6 because I'm bounded. And so that means that my point is pi over 6 and root 3 over 2. So f inverse prime of root 3 over 2 is equal to 1 over f prime of pi over 6. Right, not too bad. Well, I know the derivative of cosine is negative sine, so negative sine of pi over 6, which is just 1/2. Right, that is it for this video. I will see you all later.